Hello programmers, I've got a class here called Alphabet Soup, and remember when you were a kid and you had this soup where the noodles were in the shape of letters and you might eat a bunch of letters and end up spelling a word with what's left? Well, we've got the number of letters that are left in your bowl of soup and the actual letter values, the char or the character values. And I've got a constructor for Alphabet Soup. I can tell it's a constructor because the function has the same name as the class. It's a default constructor because it doesn't take any input arguments. So what happens when you create an Alphabet Soup object is we ask how many letters there are. We'll fill in that. We made it public just so we could easily get to it in main if we want to. We'll fill in that public field number of letters and then use that number of letters to go through a for loop that many times and read in the next letter. And then to display the alphabet soup, we're just going to print to the screen all of the letters in our alphabet soup. So I'm going to start out by creating an alphabet soup object. So when the constructor is called, it asks how many letters there are. And let's say I've eaten all but 3 of the letters, and they spell out the word M-O-M for mom. And I've got some display statements that'll display the word mom and the alphabet soup string. And I've also got a cout statement to show the bytes of storage that are being taken up. Well, you look at the size of the soup.letters field, and it's not surprising that it takes 12 bytes of storage because a char takes 1 byte and we've got an array of 12 chars. Well, it's pretty inefficient if your word is mom to have all those empty bytes because you're not using all 12 of those letters. So what are the alternatives? Well, you could make it just 3 bytes of storage and it would work for mom, but what if you had a bigger bowl of soup with more letters? Then you don't have enough storage for all of those. In fact, some really big bowls of soup might have 100 letters or 1,000 or 10,000, and we'll go ahead and run this and we'll see that if we just have the word mom, we are sure wasting a lot of storage there. So I run it, I say I just have 3 letters, M-O-M, and we've got 1,000 different bytes that we're allocating for these letters, and we're only using 3 of them. So that's not very efficient. A more efficient way to handle this would be with dynamic memory allocation. And that would deal with pointers. I know people don't like pointers, they're a little bit scary, but we're going to have a pointer to an array of letters at space that we've allocated for those letters, and we're just going to change this to a pointer to a character, and then we need to actually dynamically allocate the memory. If we were in C, that would be with a malloc statement, but in C++, it's going to be with the new keyword. And next we have what is the data type that we're creating an array of. So it's not an int, it's not a double, it's an array of chars. And how many of them do we have in a row? Well, we can use the number of letters and figure out how big of a space we want to allocate. So this will allocate exactly the amount of space that we need based on what the user said, how many letters the user said that there would be. And that's pretty much it. Those are the only changes I need to make to the code. I'm going to go ahead and run this, and just to show that you don't have to only type in 3-letter words, I'm going to pick a 4-letter word, and I'll pick cake because I would love to have cake right now. And we see that and this is a little deceiving. Yes, it is 4 bytes of storage we're taking up, but it's not really the 4 bytes of storage for the letters for cake. It's really that we're looking at the size of this letters variable, and that is a pointer, and the pointer actually takes up 4 bytes. So if I were to pick something else, like we need 8 bytes of storage, and it's B-day cake. Oops, yeah, that still worked. Then it still says 4 bytes because it's telling me the size of that pointer there. But really, I would have to follow that pointer and look at what it's pointing to and see that it's pointing to the word B-day cake. So it's really taking more than 8 bytes of storage. If you find yourself using new to do dynamic memory allocation, there's one other thing you should do is to clean that memory up when you're done using it. So when this alphabet soup object goes out of scope, a destructor would be called, and that would be the perfect time to free any memory that we'd allocated for the alphabet soup. And I would do that with the keyword delete. And because this is an array, we'll use square brackets to say that it's an array, and then the variable letters, which was our pointer. And just to make it a little easier to read, I think I'm going to put some spaces in there. And we won't notice any difference when we run this, but it is going to clean up that dynamically allocated memory and release that, so the rest of the program can use that memory. It doesn't matter so much in this simple little program that's going to, it's just going to run and take just a few seconds, but for a program that's running for months or weeks or years, we don't want to be sucking up the memory and never giving it back. Once we don't need the memory anymore, then we want to release that. So let's just try one more example. So we'll do another 3-letter word, and this time I'll do CAT for cat. And the 4 bytes of storage, remember, is just the size of that pointer. Really, if we follow the pointer and see what it's pointing to the dynamically allocated memory that has C, A, and T inside of it. All right, thanks for watching.